We all know that the concept of data analysis or research, to be specific, is all about answering burning questions with data. Now, at the center of research analysis or data analysis, okay, we have the concept of sampling. And from sampling, we have sample. So, first thing first, let's try to have a bit of a context. So, the total available data regarding anything that you're interested in is called the population data. For example, the population of people in Nigeria, the population of people all over the world, and all of those things. So, before you begin your research, you have to define your population data. Okay, very, very important. And then the variables that you are interested in this population data. Now, whenever you want to perform research, you can never use a population data to perform research. In fact, if you go through any person's research work, they've never had to use a population data to perform research. That's never possible because, number one, population data is usually extremely large to work with. Number two, it is expensive to work with. And number three, it is ideal in the sense that you can never have access to the population data as a whole. Take, for example, Nigeria. We have, the last time I checked from a WHO, we have 220 million people right here in this country as at 2022. Trust me, if you want to make a research on Nigerians, you can't have access to all these 220 million people. That is the point I'm trying to make. So the best bet that you have is to extract or make use of a fraction or a part of the population, and that is the sample. So basically, a sample is an extract of a population. Now, in statistics or in research, whenever you are removing a sample from a population to make research, the sample should be what we call a perfect representation. So that means the sample should be able to represent every aspect of the population. So let's say you have a population of 2,000 people or 2,000 things, and you want to extract a sample of 10 or a sample of 50. That your sample should represent every aspect of that population. Now, let me take, for example, my university. I'm from the University of Lagos, and I think the last time I checked, we have I think 7 faculties or 8. I can't really remember. Now, if a researcher wants to make research about the University of Lagos across the faculties, the researcher has to take a sample such that it has to cut across all of the faculties. Okay, let's say, for example, we have 50,000 students in the University of Lagos. That is the population data, right? Okay. Now, extracting a sample of 40,000 might sound like a good idea. Yes, it's actually huge, it's large, it's very, very close to the population. That's fine. But this 40,000 might not be a representation of the whole population if it was taken from just 3 faculties. Okay, and you neglect just the other faculties. But if I have a population of 50,000 students and I take, let me say, 1,000 from each faculty, from faculty of science, from engineering, from social sciences, and I have 8,000 or 9,000 sample, that 9,000 sample is a better representation of the population compared to the 40,000, because that 9,000 has tried to come across all of the categories, in quotes, in this case, all of the faculties that makes up the university. So when it comes to sample or sampling rather, it's not about how large your sample is. Yeah, your sample may be large and not cut across the necessary categories that makes up a population. So, but your sample, for it to be a perfect representation, okay, of your population, it has to cut across all of the categories that makes up a population. Then that way it becomes a perfect representation. So in simple terms, or in summary, sampling is not about the size. Okay, it's really not about the size. So that being said, statisticians and mathematicians and scholars were like, okay, you know what, let us come across, or let us bring about what we call the concept of sampling techniques. So these are steps, statistical techniques that we use to extract sample from data sets, okay, from a population data. Now we have a couple of them, and each of these techniques, they have their downsides, okay, and they have their use case scenario. So if you find yourself in certain scenario, you should use this type of sampling technique, and if you find yourself in this, use that. So basically, to make things easier for us, there are 2 types of sampling techniques in the world of statistics. We have what we call the probabilistic sampling technique, and we have the non-probabilistic sampling technique. Now, from the way these words are spelled out, you can sure understand what they are trying to, talk about. One of them is introducing the concept of probability into the sampling such that there is no form of bias, or bias is being reduced, or we can say every member of the population has an equal chance of making it into the population group. And we have the non-probabilistic, which is the type of sampling technique whereby there is a form of bias and every member of the population group, okay, does not have equal chance of making it into the sample group. So I'm going to be starting by explaining the concept of the probabilistic. No, you know what? I'm just kidding. I'm going to start with the non-probabilistic sampling technique, and then we move into the probabilistic sampling technique. I just prefer to talk about non-probabilistic. I don't know. First, it's sort of like interesting. So under the concept of non-probabilistic sampling technique, first thing first, we are not trying to introduce the concept of probability here. It means that every member of the sample group, of the population group, they don't have this equal chance of making it into the sample group. Okay, it's more or less like aristocracy or oligarchy. I don't know, I'm not a government person, but you get the chances of you making it from the population down to the sample is not equal among all of the population group. Yeah, so that being said, we have a couple of sampling techniques under this section, and the most popular one is what we call convenient sampling. You sample based on how easy it is for you to extract sample from the population. So let's take, for example, you want to sample the students of University of Lagos, and on getting to a specific faculty or the school gate, instead of getting into the school and sample based on the faculties, you just stood at the school gate and you sample the students that you could get access to. Hey, hi, do you want to participate in my survey, in my research? Oh yeah, please come. Oh yeah, so you sampled based on convenience, and that is what we call convenient sampling. It's one of the simplest and the easiest way of sampling, but I'm sure right now you can see the bias. What if you end up sampling a particular aspect of students? Maybe some students are still in class the time where you are performing this sampling, and these students that are in class would obviously have like a huge effect on your sample. So that is what we call the concept of convenient sampling. And the next sampling under the non-probabilistic is what is called the purposive or judgmental sampling. Now, this type of sampling is done based on your own intention. So you sample based on the fact that, okay, I like this, join me. I don't like this, go away. So because of the fact that you are tasked with sampling University of Lagos students, and you stood at the gate, you're like, oh, I want to sample tall people today, and you just sampled anyone above 6.5 feet. Oh, I want to sample people that are probably light skinned or dark skin rather. Okay, so that right there is purposive sampling or judgmental sampling. You sample based on your own intentions, you sample based on your own judgment, as simple as that. Now, I can tell you there are a lot of bias on this one, very, very much in that. Now, the third one is what we call the quota sampling. Now, the quota sampling is from the word quota. It simply means that you divide your population into smaller groups, okay? Like, okay, this group here, this group here. So, University of Lagos students, okay, you know what? I divide you guys based on this group, based on that group. Now, each of this quota, you take a specific number of students from them based on either convenience or judgmental. So you can just say, you know what, I want to group the students in this case based on time. So you go between 8 to 10, then 10 to 12, or you go on Monday, you go on Wednesdays, you go on Fridays. So that is a way of you having a quota, like just a group of people for Monday, group of people for Tuesday, group of people for Wednesday, and stuff like that. Then for each of this quota, you will sample probably based on judgment or based on convenience, as simple as that. Now, so far, I'm sure you are already you can imagine the bias, the sentiment that is attached to the concept of non-probabilistic sampling technique. Now, the next one is what we call the snowball sampling technique. And this is quite a simple one, because you get to University of Lagos and you see like 10 students walking out, and you tell them, hi, I want to perform this survey, but I don't think I have access to University of Lagos students. Can you help me to perform this survey? So you sort of like outsource the research or the sampling to these students. Okay, now these students will take your proposal or your offer and get into the university and start trying to sample. Oh, and they get that, oh, we have a test, I'll be busy. They now also take that research or sampling process and also outsource it to other people. Those people too outsource it. So that way we have what we call a snowball effect, where a lot of outsourcing is being done just because you want to sample. Now, this form of sampling is very, very common when somebody is in, probably, let me say, one continent, like let's say is in USA, okay, and the person is interested in probably making a research in people in Nigeria, in Lagos to be specific. So he can't just come to Africa, come to Nigeria. He's going to ask a friend. That friend is going to ask a friend. That friend is going to ask a friend until they get somebody in Nigeria. Now, the person in Nigeria is going to get somebody in Lagos, and which is going to make the research, hoping that the person in Lagos does not also outsource the sampling or the research to somebody else. So the higher the number of people in between the main guy and the end guy, the higher the error that the whole research is being prone to. And the last one, we also have what we call the concept of volunteer sampling. So as the name implies, you sample based on how much the members of the population are willing to participate in your survey or in your research. So, hi, I volunteer to be part of your sample. Oh, you're interested in mine? Oh, then come. That is volunteer sampling. As simple as that. Like, that is just what we literally mean. It's actually quite simple, just like that. So far so good. You can see that all of these non-probabilistic sampling technique, they have a lot of bias to them, and that is why the concept of probabilistic sampling techniques comes into the picture. But I'm sure you're asking yourself, are you not telling me that we don't use non-probabilistic sampling technique? Trust me, we do. In fact, we do it more in exploratory research, and most times when the concept of probabilistic sampling is not practical enough. So it has its own use case, it has its own scenario where it can be used, just that it may not be as accurate as the non-probabilistic. But as we used to say in Nigeria, a bad child has its own days. A clock is always right twice in a day. So it has its own use case scenario, and that now leads us to the next one, which is the probabilistic sampling techniques. Okay, yeah, so this one is the one that tries to reduce bias in any way. It tries to make sure that every member of the population group has this equal chance of making it from the population down to the sample group. And I think we have like 5 of them. Yeah, definitely. Some people will say there are more, but we have like 5 of them. And each of these guys have their use case scenario, when to use them and why you are using them. So I'm going to be starting with the most popular and the first one, and that is the concept of the simple random sampling technique. Now, as the name implies, it's very, very random. Okay, the fact that in this case, all the members of the population group, okay, are given a number 1, number 2, number 3, number 4, down to the last person that makes up the population. Okay, and then you would now take all of this number. It's like a lottery. Okay, you take all of this number and you drop it in let's say like a big bowl that you can now roll. Roll, and then you randomly pick a number. This way, every member of the population has an equal chance rather of making it from the population down to the sample. Okay, so for example, let's say we have a total of 100 population. So every member in this case has a 1/100 chance of making it from the population group down to the sample group. Sounds like a good one, right? Yes, but it has its own limitation in the sense that, number one, the population needs to be homogeneous. So that means the population needs to be uniform. You can only perform this sample, these techniques of sampling on population that they are not different categories attached to that population. So for example, a population of Nigeria is heterogeneous in the sense that we have different people based on different things, based on religion, based on ethnic group, and blah blah blah. So if you want to perform simple random sampling, your population needs to be homogeneous. Like, I mean, it has to be like everybody needs to be the same. It has to be uniform. Like, they are all whites, they are all black, they are all Muslims, they are all Christians. Everybody is uniform. Another limitation of this type of sampling is that the population needs to be finite. It means you have to have just a small population. It can't be large. You cannot use random sampling for anything like 1,000, 2,000 population. It's too much. It can only work on this small size of population. So the next type of probabilistic sampling technique is what we call the systematic sampling technique. And in this case, you are trying to extract a sample from your population based on a system, aka based on a periodic approach. This means you are picking every member of the population to make it to the sample group periodically. Let's say you are picking every 10th member of the population, every 20th member of the population, every 30th member, and stuff like that. Now, one of the steps you have to take whenever you want to use or perform systematic sampling is that first thing first, you have to determine the size of your population. So that means you need a finite population, a small population, just like the simple random sampling. Then you also need to determine the sample size. So that means, okay, I have a population of 1,000 people. My sample should be 200. So you need to determine your population size and you need to determine your sample size, because these two numbers is what you're going to be using to determine the interval at which you are going to be using to pick your population to make it into the sample. So for example, let's say you have a population of 1,000 people and you want to take just 100 people. So that means uppercase N is 1,000, lowercase n is 10. Okay, so the interval k is equals to 1,000 over 10, yeah, which is equals to 100. So that means you're going to be picking the 100th position variable in your population will make it into the sample group. So that's 1,000 over 10, that is 100. So that is the 100th, the 200th, the 300th, the 400th, the 500th, down to the 1,000th. You know, so that is like the concept of systematic sampling. Also, it has its limitations, and the first one is that you must have like this small population, a finite population. Number two is that the population also needs to be homogeneous. But one of its good sides that makes it different from the simple random sampling is that it's usually it can work on large sample data sets, because it can accommodate since it's based on interval, it can accommodate huge amount of data sets. Now the next one is what we call the stratified sampling. Now, stratified random sampling is one of the very popular and one of the effective sampling techniques that we have in the world of research. Now, in the sense that one of the defining properties of this one is that your population can be heterogeneous. It can have multiple, things that defines it, no problem. So, under stratified sampling, you are going to first divide your population into smaller groups known as strata. So let's say population of Nigerians, you can divide based on age group, based on gender, based on religion, based on ethnicity, based on skin color. So you just divide the population based on groups that you are interested in rather, okay? Now, once you've done that, we have groups, group 1, group 2, stratum 1, stratum 2, stratum 3, like that. You will now randomly sample each of the stratum. Okay, so that means for age group, you take this number of sample randomly. For gender, you take this number of sample randomly. For ethnicity, you take this number of sample randomly, and you keep going that way. That is the concept of stratified sampling. That way, on doing this, you've touched every single aspect of the population, every categorical aspect of the population. Now, it has its advantage, the fact that it can be used on large amounts of data sets. The fact that the population can be heterogeneous and it can work perfectly. But one of the downside that limits the stratified sampling is that you need to have detailed information about your population, because since you're going to be dividing your population into smaller groups, okay, you need to have a whole lot of detailed information about your population. And remember, I said it's very, very hard to get information from population, but that's just it. Now, the next is what we call the cluster sampling technique. Now, this is quite similar to the stratified, because you are also dividing your population into clusters, into smaller groups rather, known as clusters. So under cluster sampling, we divide our population into smaller groups known as clusters, okay? And then instead of sampling the individuals in that cluster, we randomly sample each cluster. So we have cluster 1, cluster 2, cluster 3, cluster 4, cluster 5, cluster 6, like that. And then I can randomly pick between clusters and say, oh, cluster 5, come. Oh, cluster 7, come. Oh, cluster 15, come. That is cluster sampling. It's almost similar to the concept of the stratified sampling, just that in this case we are actually going to be sampling the clusters and not the members of the clusters. Okay, that makes sense. So, and the last one is what we call the multi-stage sampling, which is just when you combine 2 or more sampling techniques together. So for example, let's assume you first performed simple random sampling to get a group of people, and then you perform stratified on this same set of sample group. So that is actually a multi-stage sampling technique. Now, I'm sure you're asking this question. So how do you know the right number to extract from a population? Like if I'm going to have 1,000 population and I want to extract a sample, what is the right amount? Like what is the right size? Now we have formulas that can actually help us to extract the right sample from a population. Now this is something that I would like to touch later on in other videos extensively, but we do have formulas that can actually help us to determine the sample size we want to extract from a population, the right amount. So we have 2 of them. We have the Taro-Yamin formula and we have the Cochrane formula. So the Taro-Yamin formula helps us to know the sample size that we want to extract from a finite population, and the Cochrane formula helps us to know the amount of sample size we want to extract from an infinite population. So these are things that I'm going to still talk about extensively, like literally in my next couple of videos. But for now, this is everything you need to know as a refresher based on the concept of sampling and sampling techniques. Okay, so if you have any question for me, I will be willing and be ready to attend to all of them. And thanks for making it to the end of this video, and we'll see you in the next one. Yeah, bye for now.